First, I'd like to call upon stage Dr. Brijesh Pandey. He's the Principal Research Associate at Alliance for an Energy Efficient Economy. Everyone, please give a big round of applause for him. Next, I'd like to call upon stage architect Prajakta Pramod Ghodchore. She is an architect at IGBC, Indian Green Building Council. Next, I'd like to call upon stage Mr. Anirudh Verma. He's the Product Head, Smart Lighting Solutions at Bajaj Electricals. Mr. Madhur Gupta, National Manager, Lux Segment at Saint Gobain India Private Limited. Next, we have Mr. Mohak Gupta, Manager, Global Buildings Performance Network. Hi. And Mr. Saurabh Jolly, he's the VP at Signature Global. I'd now like Mr. Dr. Brijesh Pandey to take over. He'll be introducing the session and starting with the presentation.
Good morning, everyone, once again. As Richa mentioned that this session is focused on green building materials, technologies and trends. So today we will be discussing on the key issues in the building sector, basically on embodied carbon that is related to emission from the building materials. And then today we have a very good mix of panelists comprising of technology solutions providers, then material manufacturers, person working in the rating agencies, and then also people working in the policy domain. So in collaboration, we will be discussing on what is the current issues in the building sector related to building materials, and then how the innovative and low carbon product can address the growing embodied carbon emission from the building sector, and then how the technology solution providers are helping in reducing the operational carbon. What are the key benefits are there from the rating side? Let's say if you address the embodied carbon, then what are the benefits you can get if you achieve some ratings? And then from the policy side, we will be also discussing what are the current issues and addresses that needs to be addressed from the policy side so that we can reduce the embodied carbon from the building sector. So I will be providing more sectoral insights from the Indian building sector from the recently released report by Niti Aayog, which is focused on decarbonization roadmap of Indian building sector. And AEEE has served as a lead knowledge partner to co-develop that decarbonization roadmap. And after giving insights of that roadmap, I will be inviting different panelists to speak on the their key products and how their products or how their work is addressing the embodied carbon related challenge in the building sector. So with this, can I request to present my slide? Yeah. So you can see here the report present how the building sector grows over the period of time in India. And from the graph, you can see that from the current base level, that is in 2025, the total building floor space is 18 billion meters square, and which is going to increase by 2.5 times by 2070. This means the 86% of the building stock that will exist by 2070 is yet to be built. And this also presents an opportunity for us to intervene in the building sector so that the action that we will take today will decide how our building sector is going to decarbonize, how much inefficiencies we are going to lock in into the building sector, how we can address, and if we build in the right manner with the right set of technologies and with the right set of building materials, then how we will be able to reduce the emission from the building sector. So there are some key statistics that I have presented here, that in India, building sector contributes 1/3 of the India's total GHG emission. And if you see the emission breakup, then you can see that embodied carbon contributes 48%, whereas the operational carbon is 52%. And since we are going to build more in future, this means this embodied carbon percentage is going to increase in future. And since there is no current policy or code which regulates the embodied carbon in the building sector, so without regulation, the share of embodied carbon is going to increase further. Whereas for operational carbon, we have building codes, ECSBC, ECBC are there, that has been notified in more than 20 states. And going forward in future, this regulation is going to tighten. This means this share of operational carbon is going to reduce through regulations, codes and standards. But what about the embodied carbon, which is related to emission from the building materials? So how to address this growing challenge of embodied carbon? You can see that the electricity demand, which is more associated with the operational carbon, is going to increase by 5 times. This means we have to choose the material which has a high insulating properties, as well as which also serve as a low embodied carbon material. And then you can also see the ownership of AC is growing to increase from current more than 10% to 80%. So how to reduce that cooling load with the right set of materials? And then the growing challenge of data center that is going to increase. But in this session, we will be more focused on material side. So this is the current landscape of policy side. So we have, as I mentioned, that we have codes and standard to regulate the operational energy and carbon, but we don't have any mandate policies or code to regulate the embodied carbon. And if we see the whole building sector in India, these are the 5 main materials which contribute in the life cycle emission or embodied carbon in the building sector: cement, steel, bricks, aluminum, and glass. Today we have a panelist from the glass sector. He will be presenting how the low carbon glass can address, can reduce the emission from the glass side. But we need to also give focus on the cement, steel, bricks, and aluminum. We have different schemes like PAT schemes is there, then CCTS scheme is going to come, which will address the emission from the cement and steel sector. But what about the walling solution? So in India, most of the buildings are being constructed with RCC frame structure with red brick. And you know that red brick is very high emission intensive material. So how to phase down that red brick and replace that with the alternative low carbon walling solution? That we need to explore. This is the way, the methodology that has been given, or the roadmap given to reduce the emission from the cement sector. So we need to phase out the OPC cement and replace that OPC cement with the PPC and the LC3 cement. This is basically the changing the clinkerization factor of the cement. So when you in OPC, the clinkerization factor is very high, and which result into a very high emission if you are using the OPC cement. But if you substitute the cementitious material with the other alternatives, then your clinkerization factor reduces, and that leads to reduction in emission from the cement sector. Similarly, from the walling side, we need to move away from the red brick and then the monolithic concrete construction and choose for the alternative solutions like AC block, fly ash brick. Then there are other alternative walling solution like lightweight, low carbon walling solution that can be integrated into the existing RCC frame structure. So we need to explore more on those side. And this is the key recommendation of that report that give a pathway that how to reduce the emission from the building sector. And this presents that there should be a national data platform where where the big developers can start disclosing their operational as well as the embodied carbon number. And then we need to strengthen the code and its implementation for commercial buildings, and then start in phase-wise manner for the residential building sector, close the compliance gap. So this should not be a kind of you just receive a rating, but what about the actual performance of the building? So we have a panelist today from the rating agency side. She will be speaking more on what she has observed while giving certification and vis-a-vis actual building performance. Then we should mandate data disclosure and then link the incentives with the different data disclosure things. Like if your building has this API range, then it should be incentivized. And then we should target the cooling surge with the right choice of material, mandate the EPDs to disclose the embodied carbon of the materials, and then coordinate and align with the existing policies like PAT scheme and CCTS schemes are there. And then invest in the people. So right now, like there are few materials available, low carbon technologies are available, but people don't know how to use it, or they are not aware regarding those materials. So the recommendation is to invest in the people, increase their capacity so that they can start working with the low carbon materials. So with that, I'm going to close my presentation, and I would like to invite first uh, Mr. Jolly to present about their solution.
जी अगर प्रेजेंटेशन का अपॉर्चुनिटी लास्ट आता तो सारा कंटेंट ख़त्म हो जाता, मतलब काफ़ी कंटेंट ब्रिजेश जी ने ऑलरेडी दिखा दिया है. सी आई एम नॉट अ टेक्निकल पर्सन. आई हेड प्रोजेक्ट मैनेजमेंट ऑफिस फॉर अ वेरी लार्ज डेवलपर. So I think so it's more of an intent issue versus where we stand today, you know. So I will not bore you with details. I have a long presentation, but we'll just focus on what key points we need to address, you know. As a developer, what do I see? I primarily see cost, you know. When I'm looking at a product, I'm looking at cost, you know. Customers see that I'm marketing because of green building products. The legislator looks at greater FAR in terms of compliance and tolerance, you know. But actually, is sustainability only for certification? I think so we need to change that norm physically and move towards a greener solution. So the shift has to happen from certification to actual implementation. And the developers will have to take a lead for that, you know. So see, so I think so. A lot has been said earlier as well, but what is important to note is that you will see that how the perception changes. You know, as a developer, there is a different perception. As a regulator, there is a different perception, and as a customer, there is a different perception. So we need to, I believe, change these perceptions. Brijesh ji, I think so, rightly mentioned that we contribute as construction to 40% of the greenhouse gas emission, and of course, Brijesh roadmap was till 2070, but I am myopic in my view. So if I say 2035 also, we still need to make 60% of our buildings. So we contribute substantially. For anything to take into effect, there are enablers for that. So if you start integrating the enablers, you will find that a lot has to happen from the initial designing stage. This cannot be left to a post-mortem decision that now law has changed, governance has changed, and I want to shift. It has to be embodied within the design aspect. So when you start conceptualizing, you need to build this in. Rightly so, I think so. Carbon concrete contributes to 35 to 40% out of the overall impact. Next would be the steel. There are other panels than just the steel and concrete. Just look at point one, for example. India is known as a. I was attending a conference in Pune last week. So we were known for our courtyards. आप जो पुराने महल बने हैं, किले बनाए, उसमें कितना अच्छा courtyard और lobby रहता है ventilation के लिए. We are now all pushed towards a glass facade. Means the decision which we take for a glass facade today, I think so that impacts the next 25 years of energy consumption. So we have lost the basics, the floor to height ratios, the window size openings. So there are a lot of things which we as concept originators have to take into consideration from day one. And that's a miss. But ultimately, देखो, मतलब जो बिकता है वही बनता है ना. तो आई थिंक सो कस्टमर परसेप्शन भी कहीं ना कहीं चेंज होना पड़ेगा. हर एक को आज ग्लास फसाड बिल्डिंग में रहना है, मतलब कमर्शियल से लेके रेजिडेंशियल वाले को भी आज ग्लास फसाड में ही रहना है ना. सो परसेप्शन भी चेंज होना पड़ेगा और अप्रोच भी चेंज करना पड़ेगा. I think so one big thing which can happen without a direct change is the prefabrication. Whatever we construct at site has lot of wastage, you know. Then you need that much manpower, that much carbon emission around it, logistic operation. So I think so there is one way of looking at things is to factorize things. If I'm making a high-rise building, 40 फ्लोर हैं, हर फ्लोर पे 4 घर हैं, तो 160 घर हो गए एक बिल्डिंग में और 10 बिल्डिंग बना रहे हैं, तो 1600 इंटू 4 वॉशरूम बनेंगे, तो 6400 वॉशरूम बन रहे हैं. मतलब टेक्निकली अगर एक छोटे से इम्पैक्ट को देखें तो 6400 वॉशरूम्स हैं. तो क्या हम उसको पॉड्स कन्वर्ट कर सकते हैं, यू नो. सो देयर आर लॉट ऑफ थिंग्स हैपनिंग विच आर हैपनिंग ऑन अ background basis, but that will impact significantly in terms of how we work at site. So modularization has to happen. We need to work on prefabrication. Technology also will play its role, you know. We all understand BIM is there. I definitely really question that also. अगर हम 2D से 3D ड्राइंग बनाते हैं तो BIM का फुल यूटिलाइजेशन नहीं है, तो 3D से डिज़ाइन होना है. बट BIM के साथ टेक्ला है, सो इफ़ यू कैन सेव ऑन दी रीबार वेस्टेज, you know, so that automatically accounts for lesser steel utilized at size. So technology will also play its vital role. Now is the interesting part where, you know, if I start in building green in my initial design, there is almost a neutral to plus 1% cost impact, you know. But 2 years down the line, now if I start thinking of what I need to do as a green building in this project, my cost impact increases to 4 to 8%, you know. So that is what I was trying to say, that if in concept stage we are mandating how we are designing, I think so we can even bring down. Like a lot of people have a misconception कि quality is a cost, you know. अच्छा काम करने में ज़्यादा पैसा लगता है. तो I would say do it right the first time is an approach. You know, when you set it right, then it becomes a process. So first time it is difficult, but next time it is not difficult. So it becomes a process. So similarly, if it is incorporated in the design from the start, it is almost a neutral cost impact even for having the green building features. You know, so I would leave everybody to just a call to action to say that, you know, whenever we are doing a final reassessment, it is the leadership which it has to drive it. Industry needs to be collaborative in terms of carbon and transparency. Policy makers need to not just focus on incentive, but also on compliance and a life cycle management system. And it starts with the developers first, where developers will have to own it. You know, we need to do it for our future generations, and there is no planet B, so this has to be an action. And for large scale projects, this is not even a decision which needs to be revalidated. It has to be a mandatory choice for all of us. So I will leave it to the other learned gentleman and the lady. Thank you.
Thank you for presenting the developer perspective and also touching the core issue of our aspiration of living in the glass building. So now, since we are criticizing the glass, now I am going to invite Mr. Madhur and see how their low carbon glazing and products are addressing this issue.
So good afternoon everyone, I am Madhur, I am from St. Gobind Glass, I take care of the large project segment. And today I think how Brijesh ji mentioned and how Jolly ji mentioned about the buildings, the need of green buildings and all that. So but I think let's start with the case that there is no difference between a building and a green building. Every building should be a green building. There is no difference in that right now. That concept, in fact that discussion should be over now. Because we have already taken a leap of last 20-25 years now when we talked about incentives and a lot of things. But now we are in a situation that every building should be green building. I don't think, in fact, from the contractors, the suppliers, everyone is focusing on the green building and even the products and the services also. So let's move to the next gen of that particular thing that we are talking about. So when we have a overall thought of that Viksit Bharat 2047, there are a lot of things that government is doing. We want economy to be 30 to 35 trillion dollars, but for that, with the growth, definitely there'll be greenhouse emissions. We have to achieve that growth by minimizing the greenhouse gas emissions. How we can do it? There are some set targets that every single individual, organization, the policy makers, everyone has to do. Government has set a very clear objective that we have to be carbon neutral by 2070. But for that, what are our short-term goals in that? The short-term goals, what we talk, government says that we have to reduce our carbon emissions, our carbon intensity by 45% from the base of 2005. That we are doing. A lot of companies, a lot of interesting things that's happening. We have to reduce our carbon footprint by 1 billion tons of carbon that we need to reduce. There are a lot of things. Energy usage, from where what is the source of that energy, that we need to change. We need to change that source from renewable and from many other sources that we can capture on that. But are our design strategies aligned to that particular thing? When we meet, I think, yes, definitely that's totally aligned in that. But there are few changes that are still required. Currently, what we are talking about energy efficiency. I don't think there is any building that any architect or any builder or any contractor is thinking of without energy efficiency. Every building is energy efficient building. There is an increased awareness about use of renewable resources. There is a reduced in the carbon emissions only by using that particular thing. Then the second topic that's most important is because at the end, buildings are for people. Somewhere, whether in the morning, whether in the evening, whether at night, people are going to use that. So well-being of the people is very important in terms of the noise, in terms of energy, in terms of the thermal comfort, acoustics, visual comfort, that we need to be very careful about. And the last is, because at the end, buildings will be constructed by some resources that we need to be very careful of. What are the resources that are getting used to construct that particular building? Are we maintaining, are we taking care of the construction waste properly or not? If we are not doing that, I think that's what we need to look. And to a surprise, when I was just going through the data, only whatever is the construction waste that is generated, only 1% is getting recycled as of now. 1%. That's too low for a country like India, where the construction, where 80% is yet to be constructed, where a lot of residential homes are going to get constructed, where there will be a lot of office space that will be required. So what we are going to give to our next generations, that we need to be very careful and we need to give it to the... So then the concept that comes to be the circularity. When we talk about the circularity, there are three. First, we need to conserve whatever we have. Second is we need to design to eliminate the wastage. I think what Jollyji mentioned, that if we make it more, construction is happening at a different location from the site. I think that's the major thing that will save a lot of things, because that will give us ideas on how we can reuse the waste, how we can reduce the waste. That are the major things that we need to see, and manage our construction waste. I think that is the biggest thing. If we go to any landfill, sadly, but that's true. We have got in NCR, we have got every border area, we have got something there that we can go, we can see, and a good percentage. And a good percentage there is of the building materials. That we need to take care. How we can do that? Because that cannot be used for energy generation, because that's creating a lot of another mess to the situation. So there is an infinity loop for any product. When we talk about it, there's a product design, then it's a production, then it's used for a particular building after a life cycle, then that product will go for some collection, or we can say the landfill, how we can correct it, and then there is a recycling, reuse, and there is a recycle. Now coming back to my topic from where Jollyji said, so glass is one material which is 100% recyclable. 100% recyclable metal, it's light. It's the only material that connects inside of a building or inside of any buildings that we are talking about to the exterior world. So it all depends on how we design, how we are going to use. There are buildings, because there is a total science behind it. I think Brijesh ji is working a lot with our R&D teams on different subject matters that we are talking about. We have architect Dipankar also here. I think I know him from last 14, 15 years. I think whenever we used to work together, I think it was always like, Madhur, I need a glass which is best for the energy efficiency. You tell me, if it is not, don't talk to me. So that kind of a motivation, that kind of a thing that we need from everyone that we're talking about right now. So glass, let's start with the glass. And glass, first thing, it's a material that creates a barrier between outside and inside, and there's a light that comes in. But why that? Is that light important? Yes, it's very important because it maintains your circadian rhythm. It allows you to think better. It allows you to prepare better. You know the difference between day and night. Because some of the people, some of my friends, they're working for data centers, and they say the bigger issue is, if they have a morning shift, they come out, they need some 45 minutes to adjust to the atmosphere what's the light there. So that's the most important thing that need to be taken care of. So lighting is very important. So there's a study that GBC with the SGRIR research organization, they have done with GBC, and we have found out amazing results. A building that is totally covered, where there is no light coming inside, direct light, and there is a building where there are glasses with a proper light coming inside. So there is a lot of difference in that. So when we talk about glazing, and we need to do a very intelligent use of a glass. Glass is a subject matter that there are few glasses, in look and feel they are very nice, but actually they are not very good for Delhi atmosphere. They are very good for locations like Ladakh. Their work is reverse. They allow a lot of heat to come inside a building, let the heat to be retained inside a building. So that's not good for it, but look and feel they look really nice. So it's all about solutions are available. We need to use it intelligently. That's what we need to design. So based on location, south, west, east, north, how we are using that glass, that's very important. It's not that it's a glass, let's use it. That's I think the old way. That's changed. So it's a very small comparison. Let's say there is a building with a clear glass, normal clear glass, and if we change that clear glass to a high performance double glazed unit, so we can see energy usage. I think we can reduce, air conditioning load can be reduced. You can see the tonnage from like around 300 tons ke aspas ka, there is a change that comes in that information, that change that we need to bring. And when we talk about, because at the end all boils down, because we have a developer also with us, developer will come back and tell us, Baba, cost, what is the cost you are going to pay? So the cost is like, glass is one. If you use a worst of a glass and if you use a best of a glass, maintenance cost is exactly same, or in fact zero. Only the cleaning that you need to do, but the maintenance is zero. So once a threshold is over, the glass will start earning back for you because of the payback. That's what we need to take care. The capex is very important. So that's the original story. Till now what we have talked, what's happening, what has happened till now, that's the original story, that we reduce the energy consumption in a building by the use of a glass, by the high performance glasses. But what's happening right now? Because today if we talk about in 2021, only 25% of the carbon percentage, embodied carbon, will come from the embodied carbon. By 2049 or 2050, it will be 48 or 49, 50% ke aspas aayega. That we need to work on today. If we don't work today, we'll not reach to that level. So we need to be very careful on the product selection, the requirement. I'll take your 3 minutes, what you left, I'll take that. So we need to be very careful on that. So glazing, overall as a glazing in a building, that contributes nearly from 10% to 20% of the overall carbon emissions. That is there. And glass contributes nearly 4 to 12% of it. Can we do something in that 4 to 12% of the overall building? Yes, definitely we can do. So we have got a solution that indigenously developed in India. That's Ore. That's a low carbon glass. That's India's first low carbon glass that reduces it. It's manufactured by, as we talk about recyclability. Currently, whatever glass you see, it has got a recycled content of 20%. In this Ore, the recycled content is 70%. We are using 100% natural gas to produce that. We are using renewable electricity to produce that. Our plants are moving towards that direction. And I should not take the credit away from our R&D team. I think they have done a phenomenal job there. I think it was their effort from more than 2 years what they have spent on this to generate this product, and importantly to get the EPD certified for that. Now we have got a EPD, we are supplying in market, these products are available in market, we are supplying and customers are really happy. Slow and slow, right now I should not name the customers right now, but yes, I can tell you that the biggest of the Indian IT giants, they are buying this glass for the repetitively for one and another building. Only one customer has given us 7 buildings. One big consultant, one big IT company of India that has given us 7 buildings. No other glass, only the low carbon that they are thinking about. So it's about the constant effort what organizations make. And I request if someone can visit our factory in Chennai, I think you can see the efforts that plant, that's a production plant, and no one can say it's a plant. The first reference will be from the sheds, you can say it's a plant, but if you don't look at that direction, you will see it's a forest. So that's the conscious effort that company is taking from our side. So, and the other thing, because we are contributing to the very smallest of the factor, that's the next part is our Swiss spacer. There is a DGU in between. That also we are taking care. It's again a very amazing product that we're using. And lastly, I'll just take quickly. I'll just move to, in a building, if there is a clear glass and if there is a low carbon glass, if we see the difference with the low carbon glass and a performance, we can reduce the operational side by 63% and we reduce the embodied carbon by 51%. That's the scale of carbon reduction that we can do right now. So this is just one small example. If you use one building, you can see the big tower, same building, 10,000 square meter. This is the impact of carbon. It's a 100-floor building. If we change it to a low carbon material, if we just change the one material, that's glass, then 100-story building will reduce to 40-story building. That's the impact of a glass that we are creating right now to the market. So that's it from my side. Saint-Gobain, we are a knowledge partner. Just let us know if we can solve some of the problems of the customers. We'll be happy to do that. Thank you so much.
Thank you, Madhur, for giving highlights of your low carbon products and also positioning glass as a solution that can reduce the operational carbon from the building sector as well as also the embodied carbon. As you rightly mentioned, that glass is a kind of connector between the inside world to the outside world, and it is also a medium of daylight to pass from outside to inside. So it is basically connected to light, and we have our next speaker from the lighting solutions. So let's see what he is going to present and how his product is interrelated with the daylight and how it helps in reducing the operational carbon from the lighting perspective.
So hi, good morning everyone. I think it's a great day today. I've had an awesome time sitting up here and listening to folks here from the industry talking about building materials. A lot of the major chunk related to a building is touched upon by everyone sitting here. But something that's really important to how all of us feel as occupants inside that building are probably the lights that we use inside it. At Bajaj, I think we're just trying to build a lot of products which are very customer centric. It should have a good user experience in terms of the light, color, temperatures, the light output, connectivity of that product, how you interact with that product. We're trying to build good products and solutions regarding that. Great perspectives that we saw right now, right, in terms of how we can change material, how we can change product features and then enhance the entire energy saving. And what we want to do is also enhance the experience of customers sitting inside that building as well. So I've split my deck today in about 2 to 3 pieces. The first one would talk about what we do as on products, what are we intending to do in the future. Indoor, outdoor, some urban spaces, some infra spaces as well. And how we can just take about 2 to 3 conscious calls before selecting the right products, which will then give overall benefit in terms of your energy saving, in terms of connectivity, and also making your building infrastructure really future proof. Because lighting as a product essentially is very well penetrated at all levels inside your entire building. Now, what are the current challenges that all of us sitting here probably are facing is how we can save energy, reduce your carbon footprint, increase comfort for occupants. And that's what I've been talking about and harping right from the word go today. Your commercial electricity usage is about 15 to 20% only for lighting, which is significant, and when reduced, gives you a lot better efficient, lot better comfort in terms of sitting inside that building, right? A lot of wastage is also happening, trying to burn all the coal to generate your electricity, other sources of energy, trying to run that product. Apart from that, a lot of standards are already in place, but obviously with cost pressures, both at customer ends and also developer ends, we know that we'll end up buying a product that fits our bill very, very right. There are standards in place which talk about how good we can do to save energy and have the right light output for everyone. But they're often neglected. That's a word probably that I shouldn't be using, but eventually I think we will all as an industry get there. Now, lighting is a very sweet spot in terms of how we can work towards saving a lot of energy. We cannot work without light, and thanks to Madhur, we introduced the sun inside the home as well in a very controlled and a good fashion. That light is probably the best light that all of us can sit, stand, and work under. And eventually, the sun is probably not a very good helper of my industry, but we would want to recreate what the sun does in the indoor environment as well. Now, what is smart lighting? This is a buzzword for everyone, even though it's my bread and butter, but I know that a lot of people like to talk about smart lighting. They like to talk about smartphones. Anything smart looks great. I'm called smart in my office, so it's just a buzzword that everyone really, really talks about. But what it is at the core is to solve problems that exist in a building for consumers, occupants, also for facility managers as well. What we need to do is have a lighting plan, and that light needs to be leveraged to get a lot of information, data, and the end result is a good ROI and energy saving. Smart lighting has peripheral devices at the edge like occupancy sensors, daylight detection sensors. And then we are able to analyze as to how much light do we need. Do I need to actually turn off the lights, turn on the lights? And that decision-making process happens at the edge. You have a controller which understands what are the schedules, what is the program that needs to run. And then you have the lighting fixture which responds to all of this. All of this then runs in the background to collect all the data, talk to each one of these lights, and then control the entire lighting system. So what we know is a smart light is anything that you can control, schedule, and use very efficiently to provide your lighting needs. Now, there are multiple things around it which I talked about, but essentially it's just going to be one product which will deliver the correct light output at the correct time during your day. Now, we just compared 100,000 square feet office, and there are metrics that you can see probably on what kind of savings that we can achieve. There was a wave where conventional lighting lamps were then taken over by LED, thanks to a lot of government push that happened, using LED as a technology and promoting it. That saved about 50% energy, and then we are just ramping it up by another 20-30% to get to that 80% mark. So if you were spending maybe 100 watts on a lamp, now we can do that same job in about 20 watts to overall consumption with controls, right? So there you can see, right, we saw about 15 to 20% of the energy consumed in e-commercial segment tower or office space is on lighting load, and now that becomes approximately 8 or 9%, right? So you can see the entire difference. Now, another important piece that the lighting product solves is the health and well-being. We know that we have to spend at least 90% of our times indoors. This is based on study on where all do humans interact with each other. Offices is where we are trapped mostly, and maybe other indoor spaces where we are deprived of sunlight. Now, an important thing that light needs to do is be at the correct color temperature, replicating sunlight in indoor environments. And that's what helps our body clock, our hormonal systems to respond and secrete correct hormones during the correct time of the day. There are two key hormones that interact with our body and helps have a good lifestyle and a good period of recovering from all the work that you do during the day. So cortisol helps you keep yourself active during the day. Melatonin helps you go to rest, go to sleep, and recharge for the next day. But most of us see that all of us are around blue lights all the time. So it's coming from your phone, from your laptops, from your lights installed inside your offices, at your homes. And we are deprived of that warm light content that the sunlight provides us during dusk. That is scientifically proven to help us sleep better and recharge better. And that is what we try to recreate using our human-centric lighting products. Now, human-centric lighting primarily works really, really well at places where we are trapped. So it's either an office, either a healthcare center, or either at an educational institution. And that's where the maximum impact of a human-centric lighting system can really benefit all the occupants sitting inside. Corporate offices, primarily because we spend most of our times in office interacting with our other people, a correct light temperature, whether it's too cool at a blue tint or probably at a warmer tint towards the evening, helps employees get back home, rest, and be back better next morning with all the energy. At healthcare centers, we know that patients need warm environments to sleep better, rest better, and recover better. And that's where it works really, really well. Talking about educational environments, we know that as students, we've been naughty, we've been studying at odd hours during the nights. But eventually, schools have also realized, and there have been studies as well, which talk about certain subjects being studied at correct times and at correct light outputs inside that room. So for mathematics, you need more focus, more blue light content is important. If we talk about something like history, something more creative, we need a warmer environment to study. Talking about outdoor applications, I'm not sure if this would interest a lot of you, but we do a lot of street lights, and we are building a lot of street lights which interact really, really well with nature. We look at insects, a very small example that I'm giving, we look at insects as something that we don't need around us. But insects overall on the environment have a very large impact. And our lights at the correct light temperature and the color temperatures help those insects and that ecosystem stay and thrive. And that's what helps our overall biological system to function really, really well. Now talking about ROI and financial benefits, I think energy saving is a very harped upon topic. Everyone wants to save energy, everyone wants to save cost, and everyone strives for a really, really sharp ROI. With smart products, we always target to get ROIs at around 15 to 30 months. Depends on the scale of the project, depends on the solution that we talk about, whether it's indoor environments, whether it's outdoor environments. But you save energy, the project pays you back after a certain ROI period, and then you are able to fit in more solutions because we always strive to build scalable products and scalable solutions. Few impacts that we have made using our products to overall enhance the experience of the occupants, whether it's a stadium, whether it's offices, tunnels, whether it is national highways, right? So that's where we operate. Buildings is something that we do even using technology like PoE and HCl. And that's where we would want to play to be able to save a lot of energy. So the implementation roadmap is very important. What is really, really important is to assess what you already have or you're intending to make and always have a mind to select the correct product for that application. We have a design team in-house which always works towards consulting and solving the correct problems associated to each region inside a building. And that's what we specialize designing our products reverse from that point of time. Common pitfalls that really happen is poor selection of products, low-grade products not fit for the entire lifetime. So instead of getting an ROI, you will end up paying for 2 products. And these are common problems that all of us face and must be avoided. Overall, smart connected lighting has moved away from standard thought processes. People initially were just solving for energy saving, and now products are going ahead and solving problems of how we can gather data and sew and stitch the entire system of the building together using lighting as a very important data node. So from open integration, things are moving towards a more edge environment where they can gather a lot of data from the system, process it, and help the building to solve a customized problem and unique to themselves as well. So simple action plan, you have to audit, look at government subsidies and other things to select the correct light. Solar has a great push in the market, and connected solar lights are also now available. Always choose something that you can scale, always measure, and always optimize. This is just to sum it up as a call to action for all of us sitting here. That's about it. Thanks.
Yeah, thank you, Anirudhji, for highlighting the lighting as an important load in the building sector, and also establishing lighting as a connector between health and well-being. So now we have seen that we have the builder's perspective, we have the solution from the glazing side, we have solution from the lighting side. Now we want to understand how the rating agency as a market driver are helping to reduce the embodied carbon in the building sector. And with this, I would like to invite Ms. Prajakta to present the insights from the rating agency side.
Namaskar. My name is Prajakta Pramod Godchare, and I represent Indian Green Building Council, that is IGBC, located in Hyderabad, one of the vertical under CII. Today's topic of my presentation is sustainable building measures from the design intent to product procurement. So, first of all, before starting, sustainable building is not like we picture it, like solar panels are installed, green roofs are there, energy efficient energy efficient systems are there in place. So yes, those are the factors which contribute in making it as a green building, but that is not completely a building. It starts way before that. Like if we go into the material sector, each material will be contributing to the same. So I'll be taking you around the slides so that you will be able to connect more with it. So when we say design stage, like whenever I'm drawing a line, it is giving carbon impact. So right from the design stage, if you're implementing certain things, it will be very beneficial with respect to cost and with respect to your design. So, once it is on paper, later during the procurement, what material you are choosing and what kind of product you want, that is going to cost you the hidden environmental cost, okay, hidden environmental charges. So that is known as embodied carbon. But what do you think the building's contribution is towards climate change today? So this slide, if you see, it depicts the committed emissions during the Paris Agreement. The source for this picture is UNEP emissions gap report. So if you observe here, you can see existing extraction infrastructure as well as existing consuming infrastructure. When it comes to existing consuming infrastructure, Okay. I don't know whether this is not working. Okay. So if you see existing consuming infrastructure, you will be able to see electricity, industry, transport, building, and other certain factors that will be affecting. But you see the share of buildings over here in the committed emissions. And when it comes to the Indian context, almost 32% from the construction and building sector is contributing to the carbon emission when it comes to construction and building sector. And out of this 32%, 60% is operational carbon emission, whereas 40% is embodied carbon emission, which is a pretty good amount of, you can say, contribution. So how to bring down this building level emissions? So there is a circular economy diagram on the screen. Each step will give you opportunities to reduce your carbon emissions at every stage, right from the design, your product manufacturing and transportation, your construction, your use, maintenance, and how you're repairing it, how much you're repairing it, and then eventually how you're going to recycle and reuse this particular material in your upcoming projects. So when it comes to design stage, like the very first step, first of all, effective passive designing is a primary stage to reduce your resource consumption. Then maybe second is selection of products, materials, considering the circularity and whole life cycle assessment, which we have just now seen in that picture. And third one is set your target for footprint. After this, second is the procurement stage. Although my PPT title includes design stage to product stage, procurement stage, but that is not all. After procurement also there are certain things which are going to impact your emissions. So I'll come to that later, but just before giving you a heads up that this is not ending here, again operational and demolition stage is also there. So when it comes to product procurement, you can always go for the materials which are available locally, which have low carbon emissions, and thirdly, which can be recycled, as in which has higher recycle content in it. So for example, when we say products, so on the screen if you see, there is a comparison between AAC blocks, that is autoclave aerated concrete blocks, and earthen brick. If you see the carbon emission in kgs, you'll observe that AAC block has 15 to 20 kgs CO2 per metric ton, and if it is compared with the earthen brick, it is almost 240 kgs CO2 per metric ton. Another factor is overall heat transfer. So in the second bit, if you see, AAC blocks have heat transfer coefficient of 0.7, whereas earthen bricks has 2. So if you are using AAC blocks in your building, it will also reduce the structural load. So your resources are automatically coming down over there. Second is cement, second example. So if you see like the conventional cement and compare it with PPC, composite cement and Portland cement, you'll observe a considerable amount of reduction in the carbon emission, that is kg CO2 per metric ton, from 650, 350 to 450 kgs. Then comes the steel. So low carbon TMT rebar offers high strength, ductility, and corrosion resistance, reducing overall material demand while enhancing building longevity. So as I mentioned earlier, that this doesn't stop here. There are certain operational functions as well which are going to eventually affect your carbon emissions. In that, firstly, I would like to mention highly efficient HVAC and lighting systems. Then second one is your renewable energy resources. Fourth stage is the sustainable demolition, where you can repurpose the material, like material or component, by salvaging it, by reusing it, and by recycling it. Sorry, by recycling and by reusing it. So if you see in this picture, you'll be able to observe, this is a This is a Ambuja cement building. Earlier, on the left-hand side, if you see, this is the existing site condition. And on the extreme right, if you see, this is the condition after completion. So the structure, they have maintained the same. They have just changed a few, they have done a few modifications in that. So, coming to the fourth bit, like demolition part, after demolition, how are you reusing your demolished materials? So, here are some of the examples which people are adopting nowadays. One is recycled aggregate. So, basically it is produced by crushing and washing of brick aggregates and stone aggregates. Even tiles are used for that. Then manufactured sand produced by crushing and washing of construction and demolition waste. Then you can see cement brick is also represented over there, and pavers as well. So just to conclude, achieving low carbon emissions in building sector makes business sense. Business sense in terms of cost savings, like your energy efficient systems leading to reduced operational cost, then lower maintenance and repair expenses, and reduced disposal cost as well by recycling the demolition waste. Second is enhanced asset values. So when it comes to green buildings, as Mr. Saurav Jolly has rightly mentioned, that if we are implementing it right from the design stage, its cost is eventually going to come down. But if we are doing like it in existing building by retrofitting it, then obviously it is going to cost you more. So if you are implementing certain things right from the design stage, it will give you an enhanced asset value as well. And third is risk mitigation, as in using durable materials rather than going for conventional ones, side by side reducing your carbon emissions as well. So in this manner, this will make business sense. Then a step-by-step approach is recommended. As I mentioned earlier, first you go for design, procurement, operations, and then sustainable demolition. I would like to conclude with a quote that transforming buildings from being a climate problem to climate solution just by designing efficiently, procuring responsibly, and planning for reuse. Thank you all.
Thank you, Prajakta, for giving the roadmap from design stage to procurement, operation, and demolition, and also highlighting that low carbon buildings makes a business sense. Now, I would like to invite Mr. Mohak, and we will understand from his topic that what are the policies needed to mainstream the low carbon material in the building sector.
Hi, good afternoon. Pros and cons of going last. I think a lot of things have been said already. People are already tired and bored. And add to that we are not someone who produces buildings or materials, so my presentation will not have as many pictures and graphics. So I'll still try to sort of try and make some sense and hopefully talk about some interesting things. I will just wait for a second for the presentation to come up. Yeah. So I'm representing the Global Buildings Performance Network. We are a policy think tank, and what I'm talking about today is the general trends in the factors that affect the large-scale adoption of green building materials and technologies. We know a lot of solutions have been in the market for a very long time, but why do we not see them everywhere? Why are not all buildings green buildings is the question, and I think we've heard from people there are policy gaps, there are market issues, so that is the kind of work that we try to dive into, and I'll talk about that a little bit. Very quick introduction to the organization itself. Like I said, Global Buildings Performance Network is a global policy think tank working across geographies on various aspects of green buildings and how to mainstream them into large-scale national level policy roadmaps and strategies. In India, there are a few areas of work that just want to sort of talk about very briefly. One kind of work is we know that there are certain policy initiatives the government has taken. We know the ECSBC has been brought into force now from ECBC. The ENS, the Eco-Niwas Samhita, is now the defining code for residential buildings. So we work at the state level to support the governments in actual implementation and compliance with those kind of policies. The second is health climate nexus. Important from the perspective, and I'm very happy that this came up in previous presentations as well, but oftentimes when we talk about green buildings, the narrative sort of gets lost in carbon emissions and resource efficiency in technical terms, but these buildings really have a large impact on the way we live, I mean our own health and well-being, and so therefore, how does that become a consideration within policy making is a very important thing, and that becomes a matter of like reframing the problem. How do we make green buildings important to all of us as an everyday thing, and therefore we're looking at very closely at the health and climate nexus and looking at mainstreaming that in development policy. Then we run something called the Solution Center, where we're trying to consolidate efforts across different organizations. We are co-convener for an alliance called MARG with the UN Environment Program and International Finance Corporation. And finally, I think the piece of work that I'll be talking more about today, which is about improving the adoption of sustainable building innovations. And how do we connect? We know that there are a lot of innovations happening, some at a very large scale, as the presenters we have here from large companies, but also at the very small scale. We have material manufacturers, innovators who are really coming up with very interesting stuff on the ground, and how can we sort of scale those up. So that will be a bit of the focus today. And therefore, a certain project that we're working on right now, it's called VISTA, Viable Innovations for Sustainable and Transformative Architecture. Brief overview, there's lots of different kinds of innovations happening in the built environment, and all of them required fairly specialized, nuanced kind of approaches. So there are, for example, we know that there are energy-linked solutions, a lot of focus on sustainable cooling, renewable energy, which is a beast in itself. Different kinds of materials, whether it's paints, finishes, cladding, water and waste management kind of solutions, a lot of software solutions coming up, software as a service for improving decision making, to have sensor-based systems in buildings for optimal management and so. And then there are deep tech material kind of innovations where we're really looking at the brick and mortar of the building and seeing, because I think like we've seen from previous presentations, embodied carbon is 40% of the emissions within the building, and a lot of that is coming from the bricks, from the cement, from the steel that we're using. So how do we innovate there? And that, in fact, is the focus of the current work that we're doing as well, within which you have material innovators working on stuff like alternate kind of bricks and blocks, paving materials, a lot of innovation in the concrete space. How do you make cement more low carbon? How do you bring new additives and other kinds of binders into cement? And then prefabricated components as well. So this is the focus of the work that GBPN is currently looking at in terms of the innovations. And a lot of the insights I bring in will be more focused towards that, but will be applicable also to the large scale innovations. So going with that, when we look at it from the developer's perspective, when we talk to developers, and we know Signature Global is here, we are preaching to the choir. You guys have already been stalwarts and pioneers in this space. So some of these may not apply, but we see that from a developer's end, the first priority becomes cost and speed. Am I bringing in new roadblocks into my construction process? Is it something I'm going to be able to implement easily or not? So therefore, their material selection will be based on that. And they have a trust deficit. If a new material is coming in which has to perform in the building for the next 30, 50, 70 years, so does an innovator who's coming in, are they bringing in all the quality assurances? Do they have the performance data or not? And another challenge that we see from a large-scale adoption perspective is a lot of very interesting solutions are very good on paper. They've done their piloting and they are successful. But if a developer today says, I'm going to be creating 1,000 flats, will you be able to provide me that scale of material? Then they don't have the scaling of capacity. So that is also a large systemic barrier when it comes to adoption of innovative materials. Then oftentimes there is just risk aversion. Chalta hai, abhi to chal raha hai. I think we have things in place, so why change? Why sort of bring in more complexity? So there is a fear of failure when you're working with new materials. So there are quality teams within developers' offices who will sort of refrain from reinventing the wheel. But we also see that there has been a lot of movement. I think it's been brought up by Jolly himself. Financial incentives have come in over time. Governments have provided incentives, whether in the way of FAR or some non-fiscal incentives, fast-track approvals or such, and therefore that has helped move the market. We see already that developers recognize the fact, and it was said before, that green buildings are not more expensive. Sometimes even not in terms of capex, but even if capex is slightly higher, you see that it will pay for itself in very few years. So there is a financial business case now for moving towards green buildings. The top developers in the country who are now by policy required to report on ESG parameters now find it useful to incorporate green building materials in their portfolio so that they can have better ESG performance. So there is that indirect way that policy has also influenced green building adoption. And as more and more developers are taking these things up, there is growing competition in the market. Very slowly, but I think there is some consumer awareness also that buildings can be green, and therefore there is some demand coming in from consumers as well for green buildings. So these are, from a market perspective, some of the overview insights that we see in terms of green building adoption. From the government end, there are regulatory challenges. There is lack of code integration today. For example, we see that finally now in the ECS BC 2024, there is a mention of embodied carbon, but it is still not a mandated requirement. It is still not something you are required to report on. There are still no standard methodologies for how to calculate, how to report, and those are barriers that right now are not being addressed. Circularity is even, I think, further down the line, but I'm glad that manufacturers are definitely looking at it. In the glass presentation, we saw that circularity is a key concern. Moreover, even when materials are available and I think they have made their performance visible, when it comes to large-scale adoption, they are still not brought into the state schedule of rates. Public procurement can't happen using those materials, so you don't see as much scaling up of those innovations as you would like to see. We still live in policy silos. So when it comes to green buildings, there are quite a few different ministries involved. Mahua, of course, being nodal because they are the housing and urban affairs policy makers. But the carbon targets are coming from MOFCC. The standards and the National Building Code is set by the Bureau of Indian Standards, which comes under the Ministry of Consumer Affairs. And then you have building energy efficiency norms being put down under ECSBC, which is by the Ministry of Power. And these ministries don't often, it is not easy to make them talk to each other, we know. So I think like there is that fragmentation of mandates across different policy bodies as well. And I think while we see growing movement towards some integrated decision making, but there is much to be done. The opportunity definitely still exists because green procurement is something that has been talked about a lot, and but still it is part of conversation. But we need to move to a point where there are mandated carbon disclosures and reduction targets. And these are the things that can create positive market signals going forward as well. The standards and labels, like we mentioned, ECSBC has embodied carbon now, but that needs to be strengthened and made mandatory over time. There were efforts at one point with EcoMark as a labeling system, but that has very little representation of building materials, so to say. So there are these gaps, but these are also, we know that the BMTPC has the PAC system, the Performance Appraisal Certification Scheme, which is used to bring in new materials into the market, but these are still fragmented efforts and no real action has been possible on that. The other opportunity definitely is that the government is one of the largest developers across the country. I mean, they're creating crores of houses through the PMAY over the next 5-7 years, large-scale infra projects. So how can these materials and technologies be brought into these mandates is going to be very, very important. And therefore, also the needs for these labels and public procurement kind of policies becomes very important. Uh, Moving on, when we talk to these innovators who are working in the market, who have brought in, who have done the R&D, not looking at the large manufacturers because you have the deep pockets to invest in R&D and sort of take decisions in a very different way. But when it comes to people who are working at a much smaller scale and coming up with innovative products, what are their barriers to scale? We've been trying to talk to them and sort of and get some insights. So for them, one of the biggest challenges, of course, is access to finance. They're applying for grants, they're applying for different kind of incubation programs, and it's a very long and cumbersome process, whether through public or private channels. And also they get money for very sporadic, very like short-term capital infusion they get, and it is not sufficient. There are concerns when they go to developers, sometimes around upfront costs, whether they have met regulatory approvals, what is the durability, will the users of the building tomorrow accept that material or not. So these are all challenges that they are having to respond to. And the demand in itself is fairly inconsistent and sort of uncertain because it is not mandated by anyone. So developers who want to take that leap of faith and who are interested in being and promoting themselves as sustainable pioneers, they will adopt, but no one else really has any reason to sort of look at this in a very serious fashion. Then quality and standards, being more specific about this, it is easy to say that these innovators and materials should meet all regulatory compliances, but the processes themselves are fairly tough. I think it's a lengthy process to get certifications. It's a costly process. They don't have the money to invest 10, 15, 20 lakhs over time to get all these testings done and all these certifications in place. Oftentimes in the codes, they don't even have clear categories for the products that they're developing. So I think like how do you even sort of integrate them into policy? Then in terms of the funding that they are able to get from, like we hear about Startup India and therefore like a lot of money being put into sort of startups, but what do they get money for? They get money for initial R&D and prototyping, some amount for also marketing and business development, but who's giving them the money कि आप 5 साल तक अपना product demonstrate कीजिए and उसके basis पे you create your EPD, your LCA, or you generate the performance and durability data. No one's giving them money for that. So that is where they are facing challenges. Going from pilot to commercialization, I've set up one plant, it's working well, I've provided material to XYZ projects, but now I want to go 10x. Who's providing capital for that? No one. So I think these are specific financing gaps, and if I have received a large order, I don't have the working capital to deliver on those. So I think these are we're trying to sort of figure out where those specific gaps are in the ecosystem and what can be done about that. So these are the barriers to scale that we see from a material manufacturer's perspective in the innovation space. So just to close, I think just some key recommendations. I know a lot has to be done, a lot needs to be done. We can't boil the ocean, so trying to look at some specific things where I think where policy can make a large impact. One, in terms of just direct policy and code reform. We need to move to performance-based standards. I think, again, this has come up again and again in the previous presentations. Mandatory carbon disclosures must come in, and from a whole life carbon perspective. Those tools, those calculators have to be built in. Those have to become part of your standard requirements when you're sort of applying for building clearances and such. Another key thing that we see could make a difference is a green label for green building materials. Like we know from the industry perspective there is a Green Pro certification, but that doesn't help with large scale government adoption because it still doesn't have a pathway into procurement policies. And through this green label possibly also create structured pathways of how these materials, if let's say if they're endorsed through this green label, how can they be brought into state level schedule of rates? How can they be brought easily into the national building code? Because oftentimes these processes themselves are so opaque or so lengthy or so tiresome that it becomes very difficult to look at large scale adoption. So you need efforts at that policy level. Green public procurement, definitely embodied carbon metrics have to come into procurement and bank lending criteria. We see some of this happening. We know there are some financial institutions who are now giving green loans at concessional rates for affordable housing development. If you are doing XYZ green practices, you get a 0.5 or 1% rebate on the loan that you're securing. But that needs to happen more and more at a larger scale. Uh, can we consolidate demand through PMAY, through these large public infra projects so that these innovators can actually start applying their projects at scale? And then public demonstration projects. We know that Mahua did these lighthouse projects with innovative green building technologies, but there the focus was speedy and cost-friendly construction. Now can we bring them onto a sustainability platform and say that the next round of lighthouse projects, let's demonstrate highly sustainable technologies so that these can be demonstrated and adopted at scale. So that's from green procurement. And then, like I mentioned, for these innovators, very targeted interventions are required in terms of financial support, the things that other private sector incubators are not funding. Can government sort of play a role? Can catalytic funds be provided to that end? And other kind of ecosystem support. If they are not able to generate evidence for their materials, can they be provided access to testing laboratories? I mean, there are government-led institutions who can provide subsidized facilities, but there are, n number of things which can be really beneficial for small-scale players when they're trying to bring their products into the market. So these are, I think, some of the larger recommendations I wanted to close with, and very happy to sort of hear thoughts from people on the panel, from the crowd as well, and if there's opportunities for collaboration, we're more than happy to sort of talk. Please. Thank you.
Uh, Thank you, Mohak, for highlighting the issue of scaling up the low carbon material manufacturers, which are basically small scale manufacturers, and then highlighting the policy gaps that is the incoherency between the different ministries to address the embodied carbon, and also providing some key recommendation how to address the embodied carbon from the policy side. So with this, we have come to the conclusion of this session, and we have seen the developer's perspective that if developer wants to address the embodied carbon, they have to take decision during the design stage. Then we have seen how the glazing products can reduce the operational as well as the embodied carbon. And then we have seen how the smart lighting choices can address the lighting load in the building sector. And then from the rating agency side, we have seen the pathways like from design to procurement, operation and demolition, how to reduce the embodied carbon in different process of building construction. And then from the policy side, we have understood what are the policy gaps are there, and where the interventions would come to address the embodied carbon. So now I would like to thank all of the panelists and speakers for presenting their views. Do you have time to questions? Yeah, so we can have 2 questions. So please, yeah. Mike.
Hello. Actually, I am being an architect working for some areas like airport projects as well as for a project management side, as well as for the landscape. As you said to me that the low carbon content and high insulation material. Generally, we are finding the common codes for all the building materials. But is there any specific codes that should be created for the carbon emissions for all the materials? Means it will be very good for us. That if you support like that types of, because we have national building codes, other codes are there. But if there's a specific codes for all the materials, only related with the carbon, that will be very helpful, and you can initiate to the companies also so that they will produce based on that. So that will be the good for everything, I think so, from what I observed from your speech. This is my recommendation, sir, actually.
Yeah, thank you for the recommendation. Yeah. Anyone else?
Yeah, just a minute. I just wanted to highlight that we already have in place Green Pro directory, in which you'll find all the materials which underwent the life cycle analysis procedure, and then it has been labeled as Green Pro. So maybe you can refer that if you want for your future.
Okay, if no any further question, then I would like to conclude this session. Is there any other question?
Is this Green Pro directory available?
Yes, it is available online. You can always check to our website and you'll get it.
Okay, thank you.
Okay, thank you everyone for this session. Now I would hand over to Richa.
A very big round of applause to all our speakers for sharing their great insights on this topic and answering the question about having standardized book for even the Green Pro products. Okay, so now we would like to present all our speakers with mementos. So I would request Mr. Brijesh Pandey to come and give the mementos to each of our speakers. I'll call the names. Uh, just, yes, Mr. Mohak Gupta, please come on stage. Yeah. Architect Prajakta Pramod Ghodchore. Mr. Anirudh Verma. Mr. Madhur Gupta. And Mr. Saurabh Jolly. May I also request Mr. Madhur Gupta to give the memento to Dr. Brijesh Pandey, please? Uh, can we have a group photo of all the speakers for this session?